All right. Problem 3 on the integration by partial fractions presentation worksheet that I gave you. Number 3, it had a 4 here, and I changed it to -3, so it had a better x-intercept. And I'm going to go through this one. The first part of it's okay. You should be able to do the first part, but then the last part, if you want to know how to work through it all the way, you can watch the video completely to the end, but it gets pretty darn messy. All right. To factor this, if you just type this in a graph on a calculator, you'll see that it goes through, the only x-intercept is at +1, so that means x minus 1 must be a factor. And to find out what the other factor is, you can divide this in there, or if you remember synthetic division, you can use what makes this 0, 1, and synthetically divide it into the 3x to the third minus 2x squared plus 2x minus 3. And you get 3 times 1 is 3. Add them and you get 1. Multiply, you get 1. Add them, you get 3. Multiply them, you get 3. Add them, you get 0. And it goes in evenly, and leaving, this was x to the third, so this is 3x squared plus x plus 3. Now, you can check that by multiplying x times all these and minus 1 times all those and add them up, and you should get that, if I've done it correctly. So we have, and this doesn't factor, and so therefore we have two factors. So the rules of integration by partial fractions says that's a linear term, so we put a over it, and we put bx plus c. Since it's a quadratic factor, I'm going to do bx plus c over this. And then to figure out what the a, b, and c are, we multiply by the common denominator, or make common denominator. So this one would have to be multiplied by that numerator and denominator. And this one would have to be multiplied by that numerator and denominator. And those together should make x squared plus 4. So I'm going to write x squared plus 4 should equal a times that plus bx plus c times x minus 1. And now I'm going to solve for a, b, and c. I'm just going to use matrices, so I'm going to look first at, looks like I got x squareds on both sides, so I'm going to look at the x squared terms. I got 1 here equals, and over here I have 3a and b and bx squareds here, and no cx squareds. And then I'm going to look at the x's, and there's none on the numerator of this. And here I would have a x's, and here I'll have, from this times this, I'll have minus b x's, and from c times this I'll have plus c x's. And then for the constant, I have a 4, and over here I'm going to have 3a and bx. That won't have b a constant because it's got the x, and the c times the x won't, but the c times minus 1, so minus c. So there's the layout. And then I got to solve for a, b, and c. Now, the easiest is to do this on a calculator, I think. You might be able to do it some other way, or you might be good at some other way. But I'll pull up my calculator. type in matrix, edit, 3 by 3, and let's see, I have a 3A, a 1B, and no C's, 1A minus 1B, and 1C, 3 A's, no B's, minus 1C, and then matrix B, edit, matrix B. That one's going to be 104. 104. Quit. Clear. Matrix A, inverse. Matrix B, math. Enter. It's telling me A is 5/7. So A is 5/7. Let's put it over here. So this becomes 5/7, the integral of 1 over x minus 1 dx, plus the integral, and B was negative 8/7 x, plus C is negative 13/7, all over 3x squared plus x plus 3 dx. Okay. This part, if you let u be x minus 1, do the integration, you get 1 over u du. So you get 5/7 ln absolute value of x minus 1 for this antiderivative. This one is a pain in the rear. Now to start with, I see both of these are have it's like there's a 7th and a minus times this, so I'm going to pull out a minus 1/7, and that would leave negative 8 plus 8 x plus 13, and in the denominator I am going to pull out a 3, which would mean I'd have x squared plus 1/3 x plus 1. Okay. Now I'm going to complete the square on this denominator because I think I'm going to try to get an arctangent looking thing going. And so this part's going to keep coming along. So I'm just going to call this blah, blah, blah. Minus 1/21 integral 8x plus 13 over, now if you remember completing the square, if this is a 1, you take half of this, so I'm going to go x squared plus half of 1/3, and I'm going to put that in here and square it. Now if I were to multiply this out, I would get x squared plus 1/6x plus 1/6x plus 2/6x, which is 1/3 x, but I'd also get plus 1/36, and I don't have that here, so I need to take away 1/36, and I have a plus 1. Okay. Now I'm going to combine these two. So I have this minus 1 over 21 integral of 8x plus 13 over x plus 1/6 squared plus 35/36. And then I'm going to make this one by factoring out a 35/36 in the denominator. So I'm going to have this minus 1 over 21, and I'm pulling out in the denominator 35/36. So I would have 8x plus 13 over 36/35 x plus 1/6 squared plus 1. Now just to clarify, dx. This times this would be 1 times this, which I have, and this times this would be the 35/36. So you see how I'm factoring that out. So I have this still, and I'm going to invert. I'm dividing by this fraction, so it's going to be minus 1 over 21 times 36/35 integral 8x plus 13 over, and now I'm going to push this into the square. So if it came out of the square as this, in it, it's the square root of this. So it's going to be 6 over the square root of 35x plus 6 over the square root of 35 times 1/6 squared. So you can write this plus this times itself and square it out. You should get something that looks like this. Plus 1. So then, told you this was getting messy. And so we have all of this. See, 3 goes into this and into this, so I get minus 12 over 7 times 35. I don't know what that is. 7 times 35. I could figure it out, but I'm not going to worry about that for right now. I have this, and these 6's cancel here. So I have 1 over the square root of 35 and 6 over the square root of 35. I am going to do u sub for that. 6 over the square root of 35 x plus 1 over the square root of 35. So du is going to be 6 over the square root of 35 dx. So dx can be replaced with square root of 35 du over 6. So what I would get is, now if that's, I got to get rid of the x, and there's not going to be an x to cancel it from the derivative here. So I need to solve for x in this, and you see how this is getting messy. It's going to be u minus 1 over the square root of 35 equals 6 over the square root of 35x. So I need to multiply both sides by the square root of 35 over 6, which would cancel that, and I get x equals square root of 35u over 6 minus 1/6. So I'm going to put that here. So I have 8 times that. 8 square root 35 over 6 u minus 8 6 plus 13 over u squared plus 1. That's what I was going for, something that looks like arctangent. And dx is going to be replaced with square root of 35 over 6 du. A lot of mess. So then, this can be pulled out, and I'm going to pull a 6th out. Well, I'm going to reduce this. This is going to be 4 thirds. 4 thirds. So let's see what we come up with here. So we have that, which we did right away, minus 12 over 7 times 35. I'm pulling out the square root of 35 over 6. Integral. And I'm going to have 4 square root 35 over 3 u over u squared plus 1. And then I'm going to have minus 4 thirds plus 13. So that's going to be, that's 1 1/3 from 13. So that's 11 2/3 over u squared plus 1. The integral of this is going to be, since that pulls out, is going to be 11 2/3 times the arctangent of u, and u is going to be that. But this one, I'm going to have to do a substitution. Because I have this in the numerator, I can let something be that. So I'm going to let z be u squared plus 1. dz would be 2u du. And so I can replace du with dz over 2u. So I have that. That's that squiggle. I have this gunk. 6 into there's 2, so I have minus 2 over 7 times 35 times the square root of 35. And then this pulls out of this integral, 4 square root 35 over 3 integral u over z. Du is dz over 2u. The u's cancel, so I get ln z. and z is this, and u in that is that. So I got to clear back to there. I want to finish this up. Plus, this is 11 and 2/3 arc tangent u. So let's see if I can write this. 5/7 ln absolute value x minus 1 from way back up here minus 2 square root 35 over 7 times 35. I think that's 245. But anyway, that times this 4 square root 35 over 3 ln z, which is something u squared plus 1, and u was 6 over the square root 35 x plus 1 over the square root 35. So that is back to x's for this part, plus 11 and 2/3 arc tangent. 11 and 2/3 arctangent of u, absolute value, and u was, again, this, so that's 6 over square root 35 x plus 1 over the square root of 35. And that closes this parenthesis that has this times this plus c. I expect you to be able to go to there. After that, all of this stuff is why I didn't do it in class. Okay?